let's have a look at question 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water, so the water starts to leak from a small hole at a point L in the side of the tank. So, which is point L here. Okay. While the tank is leaking, the depths h meters of the water in the tank is modeled by the differential equation dH over dt equal to negative 0.12 e to the power negative 0.2 t. So where t hours is the time after the leak starts. So be careful with all the units. So t is in hours and then h is in meters. And then using the model, A show that H equal to A e to the power negative 0.2 t plus B, where A, B are constants to be found. Okay. So for part A, we just have to integrate dH over dt equal to negative 0.12 e to the power negative 0.2 t. So for this one, we don't have to use separation of variable because the expression on the right-hand side is just in terms of t. So there's no h in it. So we don't need to do separation of variable. We just have to integrate straight away. So h is just the integral of negative 0.12 e to the power negative 0.2 t dt. So that means h is equal to negative 0.12 is the coefficients, they're the same. And then since this is just a linear expression, so just e to the power negative 0.2 t, and then divide by the coefficient of t, which is negative 0.2 plus c. So simplify that, h equal to negative over negative cancelled, and then 0.12 divided by 0.2 is equal to 3 over 5. So h equal to 3 over 5 e to the power negative 0.2 t plus c. And now we need to find out the value of C. It says initially the tank is full of water. So that means when T equal to 0, so the cylindrical tank of a height 1.5 meters. So if it's full of water, that means the height of the water should be 1.5 meters. So H equal to 1.5. So then substitute in h equal to 1.5 and then t equal to 0. So that will be 1.5 equal to 3 over 5. And then e to the power 0 is just 1 plus c. So c is just equal to 1.5 minus 3 over 5, which is equal to 0.9. So then h equal to 3 over 5, which is 0.6. Let me just change it all into decimal. So 0.6 e to the power negative 0.2 t, and then plus c, which is 0.9. Then that'll be the final answer for part A. It's only 3 marks. Okay, part B. Find the time taken for the depth of water to decrease to 1.2 meter. Give your answer in hours and minutes to the nearest minute. So for part B, we want to work out time when t time, yeah, which is t. So when the height become 1.2 meter. So we just let h equal to 1.2. So 1.2 equal to 0.6 e to the power negative 0.2 t plus 0.9. So minus 0.9 for both sides, that would be 0.3 equal to 0.6 e to the power negative 0.2 t. And then divide by 0.6. So 0.3 divided by 0.6 is just equal to 1/2. So 1/2 equal to e to the power negative 0.2 t. So that means negative 0.2 t is just equal to ln of 1/2. So, and then 0.2 t should be the same as ln 2 because ln 1/2 is negative of ln 2. And then, so t is just equal to, so 5 ln 2. So because divided by 0.2, 1 over 0.2 is equal to 5. So 5 times by ln 2, put in the calculator, we have t is equal to 3.46573, and then the units would be hours. But be careful about what they're asking you. So give your answer in hours and minutes to the nearest minute. So then that should be 3 hours. And then we need to change 0.4 0.46573 hours into minutes. So it comes by 60 for 0.46573. So that'll be 27.94. And they want to the nearest minute. So 27.94 is just 28 minutes. So then that will be the final answer for part B. So that's another 3 marks. And then part C, in the long term, the water level in the tank falls to the same height as the hole. So part C, find according to the model, the height of the hole from the bottom of the tank. So basically, it's just asking you what's the limiting height. So if we let t goes into infinity, so that means either part of negative 0.2t will go to 0. Because either part negative 0.2t will goes something like this, a diagram. So as t get bigger, it'll get smaller and smaller, eventually turns to 0. So which means h should turns into 0.6 times 0 just 0. So it just plus 0.9 is just 0.9. So that means the height of the hole from the bottom of the tank should be 0.9 meters.
Thank you for watching the video. If you have any questions, you can leave some comment. And then if you find the video helpful, please like it and subscribe it. May the A star be with you.